Hey my friends, in today's video we are going to be talking about how to graph an exponential function and to describe the important properties of that function. So for today we are going to be graphing the function f of x equals 2 times 3 to the x power minus 4. And I know that this is an exponential function because remember in class we talked about how an exponential function is of the form a times b to the x. So our variable is going to be in the exponent position. So since we have 3 to the x power, this is going to be an example of an exponential function. And then we also said that we were going to look at some that were a little bit more complicated and that we could add some stuff to the exponent if I wanted, or I could add or subtract some stuff down here, and how that would shift the way the graph looks. So our most basic exponential is something of the form y equals a times b to the x, where b is the base of the exponent and x is our variable. That's the thing that's changing. So we're going to look at what happens if we change that x value to different exponents and determine our y values of our function, and then plot those to create our graph. So when creating your table here for exponentials, there's no real points you have to use, but there are points that are going to be nice because exponential functions grow really quickly, right? 3 squared is 9, 9 times 2 is 18. I'm already at the really tippity top of my graph. If I put in 3 for x, 3 cubed is 27. 27 is not really going to fit on my graph paper. So we're going to try to stick with some small numbers here. So when we substitute values in for x, I'm going to substitute in 0, 1, and 2 to try to keep that exponent pretty small. But then we also talked about how it's important to get the other side of the graph, how exponents aren't just positive numbers, we could have negative numbers as well. So I'm going to substitute -1 and -2 in for x also. So those are kind of the standard 5 points I would always use when plotting an exponential. Again, we don't want to use numbers too big or really, really small because they probably won't fit on our graph paper. Okay, so now all we need to do is find the y values. So in order to do that, we need to substitute our x values into our function. So I'm going to start with 0, 1, and 2, the positive x values, and then we'll talk more about those negative x values. So if I'm going to substitute 0 in for x, that means I'm going to have 2 times 3 to the 0 power minus 4. Okay. And I need to evaluate, see what that is, and then that will help me figure out my y value. And the big thing we need to remember here is PEMDAS. Exponent comes before multiplication. The most common mistake is to multiply 2 times 3 first. That is not what we want to do. Exponent comes first. So we're going to do 3 to the 0 power. And we talked in class, reminded ourselves that anything to the 0 power, remember, is 1. So 3 to the 0 power is 1. So then I'm going to have 2 times 1 minus 4. And 2 times 1 is 2 minus 4. So that's going to get me to -2. So my first y value is -2. And that came from, sorry, I put it in the wrong spot. Substituting in 0. So anything to the 0 power was 1. 1 times 2 was 2. 2 minus 4 is -2. So then I'm going to repeat, and now I'm going to substitute in 1. So let's figure out what f of 1 is. So 2 times 3 to the first power minus 4. Again, based on our PEMDAS, exponent is coming first. So 3 to the first power is 3 times 2 minus 4. 3 times 2 is going to give me 6 minus 4. So that's going to give me 2. So when I had an exponent of 1, my y value was 2. And then to finish out our last positive one, what's going to happen if we substitute 2 in for x? So 2 times 3. My exponent's getting replaced with a 2, so 3 squared minus 4. Again, parentheses first. 3 squared is 9, not 6. Right? 3 squared, remember, is 3 times 3. So 2 times 9 minus 4. 2 times 9 is 18. Minus 4 is going to give me 14. Right? So look how big our numbers got all of a sudden. That's why it's really important to make sure we're kind of using these smallish values for x to ensure that our y values will fit on the chart. Okay, next we have our negative exponents, and I saved those for last just because they tend to be a little bit trickier, so sometimes it's nice to start out with things you feel confident in. And I'm going to just go over to the right side of my page to do those negative values. So we're going to try f of -1. So that means I have 2 times 3 to the -1 power minus 4. Remember, we're still doing exponent first, so I need to figure out what 3 to the -1 power is. Remember, negative exponents just mean fractions. So 3 to the first is 3. So 3 to the -1 is just 1 over 3 minus 4. 2 times 1 over 3 is 2/3 minus 4. And 2/3 minus 4 is going to give me -3 1/3. Or if you're doing this in your calculator, you might get -3.333. So -3 1/3 or -3.33. And now I'm just going to repeat and do f of -2. So 2 times 3 to the, now I'm doing to the -2 power minus 4. 3 to the -2 power. Again, negatives just mean fractions. So 3 squared was 9. So 3 to the -2 is 1 over 9. So I have 2 times 1 over 9 minus 4. 2 times 1 over 9 is 2 over 9 minus 4. So that's going to give me with 3 7/9. -3 7/9. And again, if you like a decimal better, sorry, I'm going to write this a little better so it doesn't look like 37. So -3 7/9. Okay, so I'm almost at -4. I'm just 2/9 away, but -3 7/9. Okay, so now I'm going to plot. Make life easy. Plot the easy ones first. So I have 2. I'm going to go over 2 on the x-axis and up to 14. And then 1, 2, 0, -2, -1, -3 1/3. So I'm going to go -3 and down a little bit more. And -2, I have -3 7/9. So that's going to be even a little bit more negative. I'm just going to erase my PEMDAS here because we're going to need some space to make our asymptote. So this hopefully makes sense to you that our graph, I have -3 1/3, -3 7/9. And we talked a little bit in class today about how this k value is going to produce your horizontal asymptote. And that means it's going to tell you what either the highest or the lowest number on the graph is. And in this case, if we were going to keep extending this table, say I went backwards and plugged in -3, -4, -5, and so on, this number is going to keep getting smaller, but it's not going to get smaller and smaller and smaller. It's going to get smaller and smaller and closer to -4. But I'm never going to actually hit -4. I'm just going to get closer and closer and closer and closer to that. And the reason that's going to happen is because there's no exponent that will make 3 to that power equal 0. So there's no way we're going to get this part of the function, the 3 to the x part, to be 0. And we would need it to be 0 in order to get a y value of -4. But by putting in negative values for x, I'm going to keep getting smaller and smaller and smaller. So then when I multiply by 2, I'm going to get smaller and smaller and smaller. And then when I subtract 4, I'm just going to get really close to -4. But I'm never going to actually hit 4. So my graph is going to look something like this. I'm going to have a horizontal asymptote at -4. So that means I'm going to indicate that with this dotted line on my graph. That means I'm going to get close to -4 but not hit it. And then I'm going to connect my points. So I'm going to start really close to my asymptote. And then I'm going to swoop up and hit the other points on my graph. And this just indicates to me that you understand that the graph is going to get closer and closer and closer to the asymptote, which is at -4, but it's never going to go below. It's not going to swoop down here. It's not going to zoom back up. it's going to appear almost horizontally. It's going to be going down and down and down and getting closer and closer to -4, but never actually hitting it. So now that I have my 5 points plotted, I have my horizontal asymptote plotted, we can answer each of these questions, so these properties. So I'm going to do my horizontal asymptote already, and my horizontal asymptote is saying the y value is getting close to 4. So it's an equation. Please don't just write the number 4. You're saying the y value is going to get close to 4, so my horizontal asymptote is at y equals 4. My y-intercept, and I know I'm going in a little bit of a funny order, y-intercept just means where do you cross the y-axis? So, right, our y-axis is right here. Well, where did I cross it? I crossed it at this point, and that point was the value 0, -2. I can also locate that point in the table right here. So this is my y-intercept. Next, domain and range. Domain, remember, means left to right. So look at the values on your table and look at the values in your graph, right? I could keep adding larger numbers to my table, 1, 2, 3, 4, 5, 6. I could keep adding lower values to my table, -1, -2, -3, -4, which indicates that this is going to keep going to the left and this is going to keep going to the right. Yes, it's going up, but it's also going, look, very slowly to the right. So my domain is -infinity to infinity. Basically, I can put any negative number in for x. I can put any positive number in for x. I can put any of those numbers into my equation, and that's why my graph's going to keep going left forever and keep going right forever. The range, on the other hand, talks about the y values in your table, or based on your graph, it talks about from bottom to top. So our graph has a bottom. It doesn't go down forever. It's going to stop going down at -4, and it's never going to actually hit -4. So our lowest point is -4, and since we're not going to actually hit it, remember we use a parenthesis. If we were going to actually hit it, we would use a bracket. But there's no way for us to possibly hit -4. We'll just get close to it, like -3.99999. So my lowest point is -4, and you can see that since the graph keeps going up, it's going to go towards infinity, right? If I kept putting in bigger numbers in for x, my y values would continue to get bigger. Next is increasing or decreasing interval. So when we look at increasing and decreasing, remember we're basically tracing our graph from left to right. And if I trace my graph from left to right, my graph is increasing. It never swoops down. So for decreasing interval, I'm going to put none, because when we look from left to right, I'm never decreasing. Sorry, there we go. None. Okay. Yes, I see that if you trace it this way, it does decrease. But remember, increasing and decreasing is always looked from left to right. If not, we would have both for everything, because depending on how you look at it, you could say it's increasing and it's decreasing. So when we do this, remember, we always look from left to right. So this is not decreasing, and it's increasing the entire time. So it's increasing on its entire domain. So we say from -infinity to infinity. And then last but not least is our end behavior, and that got cut off a little bit on mine, so I'm just going to zoom us in so we can see. And end behavior talks about what is happening on the ends of the graph. So we have two ends to the graph here, and what we're going to say is what happens as we look to the right and what happens as we look to the left. Well, if I'm going to look at this end first, this is my left end. So I'm going to say as x approaches -infinity, because notice these numbers, -1, -2, -3, -4, -5, going towards -infinity. So as we approach -infinity, if I was going to keep drawing this arrow, what y value would it get close to? Well, it's going to get close to -4, because we've talked about how it's not going to go up, it's not going to go down, it's just going to keep going straight across, getting closer to that asymptote, which is -4. Okay? And then I'm going to take a look at the other end. So look over here at the right end. This time it says x goes to infinity, right? Because as I keep going this way to the right, my x's are getting bigger. And what happens to y? Is it going up? Is it going down? Is it going straight across? Well, here it's clearly going up. So I'm going to say as x goes to infinity, y goes to infinity. Basically what we're saying is as x gets bigger, y gets bigger. And then for negative infinity, we're saying as x gets smaller, as you put in smaller numbers for x, y gets closer to -4. It gets smaller, but it's not going to go all the way to negative infinity. It's going to go to -4. So there you go. Hope that helped. An example on how to graph exponential functions. As always, let us know if you need anything. Bye.